Hi students, in the previous video I explained the AC circuit containing pure inductance. See, I have shown that voltage leads current or current lags voltage by 90 degree in the case of pure inductance. Now I shall represent that in a graphical manner and also in vectorial manner. See, graphical I can represent like this. Look at the diagram. I shall write down the graph. Okay. Nobody look at this. This is a graphical representation. Look at that. So this is in the case of pure inductance. This is voltage or current with respect to time. So this is called voltage. This is called current. Voltage leads current by pi by 2. ಇದನ್ನ graphically ಅಂತ ಕರೀತೇನೆ. Graphically. See, voltage leads current. Current lags voltage. Current lags voltage. So vectorial ಆಗಿ ಈ ತರ ಬರೀತೀನಿ. So vectorially I can represent like this. Vectorially I can replace. Not I can arrange like this. Vectorially voltage leads tane. Voltage lead ana hinge baribeku. Nodi. See, voltage leads current. Fine. This is how we can represent. This is called V. This is called I. Voltage leads current by pi by 2 radian. Look at this. Athwa I can say idan ingo baribodu. Current lags voltage. Current lags voltage. Nodi ingo baribodu. So this is called I. This is called V. Ingo baribodu. Okay, makla? Look at this. So this is how we can represent the variation graphically and vectorially. So this is vectorial representation. This is vectorial representation. Nodi, ಎರಡು ಕೇಸಲ್ಲಿ ಗೊತ್ತಿದೆ ನಿಮಗೆ voltage leads current by pi by 2 or current lags voltage by pi by 2 radian. Okay, ಮಕ್ಕಳ? Fine. ಇದು ನಿಮ್ಗೆ ಗೊತ್ತಿರಬೇಕು. ಸೊ ಆ ಗ್ರಾಫ್ ಅಲ್ಲಿ ನೋಟ್ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಬರ್ಕೊಂಡಿರ್ಬೇಕು ನೀವು ಇದನ್ನ. ಗ್ರಾಫಿಕ್ ಬರಿಬೇಕು ಅಂದ್ರೆ ಹೆಂಗಿರುತ್ತೆ, ವೆಕ್ಟೋರಿಯಲ್ ಆಗಿ ಹೆಂಗ್ ಬರೀಬಹುದು ಇನ್ ದ ಕೇಸ್ ಆಫ್ an AC circuit containing pure inductive circuit. Okay, now we have in the case of an AC circuit containing pure capacitance, we have seen this. ನೋಡಿ ಇಲ್ಲಿ ಗೊತ್ತಿದೆ ನಿಮಗೆ, ನೋಡಿ ಇಲ್ಲಿ ಗೊತ್ತಾಯಿತು ನಿಮಗೆ. What is that? I naught is equal to omega c into V naught, correct? So we have I naught is equal to, again note point, we have I naught is equal to V naught into omega c. ನೋಡಿ we have ಗೊತ್ತಿದೆ ನಿಮಗೆ ಇಲ್ಲಿ ಆಲ್ರೆಡಿ. ನೋಡಿ we have I naught is equal to omega c into V naught. ಅದೇ ಬರೆದಿದ್ದೀನಿ. omega naught ನೋಡಿ I naught is equal to V naught into omega c. ರೀಅರೇಂಜ್ ಮಾಡ್ಕೊಳ್ತೀನಿ ಅಂದ್ರೆ ಮಕ್ಕಳ, V naught by I naught is equal to 1 by omega c. Look at that. What does the term P naught by I naught indicates? Kind of opposition to the flow of AC. That opposition is called capacitive reactance denoted by XC. XC is called capacitive reactance. Capacitive reactance. ಕೆಪಾಸಿಟಿವ್ ರಿಯಾಕ್ಟೆನ್ಸ್. ಮಕ್ಕಳ ಇಂಡಕ್ಟೆನ್ಸ್ ಅಲ್ಲಿ ಇಂಡಕ್ಟಿವ್ ರಿಯಾಕ್ಟೆನ್ಸ್ ಬಗ್ಗೆ ಹೇಳಿದ್ರೆ, ಇವಾಗ ಈ ಒಂದು ಕೆಪಾಸಿಟೆನ್ಸ್ ಅಲ್ಲಿ ಕೆಪಾಸಿಟಿವ್ ರಿಯಾಕ್ಟೆನ್ಸ್ ಅಂತ ಕರಿಬೇಕು. ಓಕೆ, ಇದು ಕೂಡ ಅಷ್ಟೇ. ದ ಎಫೆಕ್ಟಿವ್ ಅಪೋಸಿಷನ್ ಆಫರ್ಡ್ ಬೈ ದ ಕೆಪಾಸಿಟರ್ ಟು ದಿ ಫ್ಲೋ ಆಫ್ AC. Now what is called capacitive reactance? Question ಬರೀತೀನಿ ನೋಡಿ. What is capacitive reactance? What is capacitive reactance? ನಿಮಗೆ ಕ್ವಶನ್ ಆನ್ಸರ್ ಗೊತ್ತಿರಬೇಕು. It is the effective opposition. It is the effective opposition offered by capacitor to the flow of AC. To the flow of AC. ನೋಡಿ, it is effective opposition offered by capacitor to the flow of AC. It is given by ನೋಡಿ ಈಕ್ವೇಶನ್ ಕೊಡ್ತೀನಿ. XL is equal to 1 by omega c. I'm sorry, this is XC. This is called XC. X suffix C. XC is equal to 1 by omega c, or XC is equal to 1 by, what is omega? 2 pi F into C. So this is a required equation. Okay. This is the equation for capacitive reactance. ನಿಮಗೆ 1-2 marks ಅಲ್ಲಿ ಕೇಳ್ತಾರೆ. What is capacitive reactance? Mention its equation ಅಂತ. It is the effective opposition offered by the capacitor to the flow of AC. AC ಅಂದ್ರೇನು? Alternating current. It is given by XC is equal to 1 by omega c, ಅಥವಾ X is equal to 1 by 2 pi F. ಯಾಕೆ? Because omega is equal to 2 pi F ಅಂತ. Now terms ಹೇಳಿ. What is called F and what is called C? Where F ಅಂದ್ರೆ ಏನು? F ಅಂದ್ರೆ frequency of AC. What is called C? Capacitance of capacitor. Capacitance of capacitor. Okay ಮಕ್ಕಳ, ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್ ಇದು. ಹಂಗಿದ್ರೆ ಅಗೇನ್ ನೋಡಿ, ಇವಾಗ ಅನದರ್ ಪಾಯಿಂಟ್ ಇಸ್ ದಿಸ್. ಏನಂತ ಅನದರ್ ಪಾಯಿಂಟ್ ಹೇಳ್ತೇನೆ ನೋಡಿ. ವಿ ಹ್ಯಾವ್ XC is equal to 1 by 2 pi FC. Now how does capacitive reactance depends on frequency? Inversely ಅಲ್ವಾ? ಅಂದ್ರೆ XC is inversely proportional to frequency. ಅಂದ್ರೆ capacitive reactance is inversely proportional to frequency of AC. ನೋಡಿ, ಸೊ ಇನ್ವರ್ಸ್ಲಿ ಅಂದ್ರೆ ಏನು? ಫ್ರೀಕ್ವೆನ್ಸಿ ಜಾಸ್ತಿ ಆಯ್ತು ಅಂದ್ರೆ ಕೆಪಾಸಿಟಿವ್ ರಿಯಾಕ್ಟೆನ್ಸ್ ಕಡಿಮೆ ಆಗುತ್ತೆ. ಇನ್ವರ್ಸ್ಲಿ ಅದು. ಸೊ ಕೆಪಾಸಿಟಿವ್ ರಿಯಾಕ್ಟೆನ್ಸ್ is inversely proportional to frequency of AC. If you plot a graph, ಏನು? If you plot a graph of frequency ಅಥವಾ XC versus frequency, this is XC, this is F. ಅವಾಗ you will get a curve like this. It is a curve, XC versus frequency. As F increases, XC decreases. ನಿಮ್ಗೆ ಕೇಳಬಹುದು, draw a graph representing in the capacitive reactance and frequency. ಅಥವಾ how does capacitive reactance depends on frequency ಅಂತ ಕೇಳಬಹುದು. And lastly, what is the SI unit? SI unit of capacitive reactance is ohm again. Is ohm. ನೋಡಿ resistance unit ohm, inductive reactance ಗೆ unit ohm, capacitive reactance ಕೂಡ unit ohm. ಓಕೆ, ಇಷ್ಟೆಲ್ಲ ಗೊತ್ತಿರಬೇಕು ಮಕ್ಕಳ. ಇದು ಮೂರು ಇಂಪಾರ್ಟೆಂಟ್ ಗೊತ್ತಿರಬೇಕು. ಅಂದ್ರೆ ಇವಾಗ ಸೊ ಬಿಫೋರ್ ಗೋಯಿಂಗ್ ಟು ನೆಕ್ಸ್ಟ್ ಸೆಷನ್ ಲೆಟ್ ಮಿ ರಿಮೈಂಡ್ ಯು ಏನು, ಇನ್ ದ ಕೇಸ್ ಆಫ್ an AC circuit containing pure resistance, voltage and current are in the same phase. Their phase difference is 0 degree. In the case of an AC circuit containing pure inductance, voltage leads current or current lags voltage by 90 degree or pi by 2. And in the case of an AC circuit containing pure capacitance, voltage lags current or current leads voltage by 90 degree or pi by 2 radian. So ಈ ಮೂರು ಇಂಪಾರ್ಟೆಂಟ್ ಪಾಯಿಂಟ್ಸ್ ಅನ್ನು ತಿಳ್ಕೊಂಡ್ರೆ ನೆಕ್ಸ್ಟ್ ಸೆಷನ್ ಅಲ್ಲಿ ಏನ್ ಹೇಳ್ತೇನೆ ಅದು ತುಂಬಾ ಹೆಲ್ಪ್ ಆಗುತ್ತೆ. ಅಲ್ಲಿ ಏನ್ ಮಾಡ್ತೀನಿ ಅಂತಂದ್ರೆ ಈ ಮೂರು ಒಟ್ಟಿಗೆ ಸೇರಿಸ್ತೀನಿ ಸೀರೀಸ್ ಅಲ್ಲಿ. ಇವಾಗ ಇಂಡಿಪೆಂಡೆಂಟ್ ಆಗಿದೆ, ರೆಸಿಸ್ಟೆನ್ಸ್ ಬೇರೆ, ಕೆಪಾಸಿಟನ್ಸ್ ಬೇರೆ, ಇಂಡಕ್ಟೆನ್ಸ್ ಬೇರೆ, ಆಯ್ತಾ. ಸೊ ಇನ್ ದ ನೆಕ್ಸ್ಟ್ ಡೆರಿವೇಶನ್ ಏನ್ ಮಾಡ್ತೀನಿ, we put all these components in series across an AC source. AC source ಗೆ ಏನು ನಾವು ಈ ಮೂರನ್ನ ರೆಸಿಸ್ಟೆನ್ಸ್, ಇಂಡಕ್ಟೆನ್ಸ್ ಅಂಡ್ ಕೆಪಾಸಿಟೆನ್ಸ್ ನ ಸೀರೀಸ್ ಹಾಕ್ಬಿಟ್ಟು ವೋಲ್ಟೇಜ್ ಅನ್ನು ಕೊಡ್ತಾನೆ, AC ನ ಕೊಡ್ತಾನೆ. ಆವಾಗ we shall establish what is the effective opposition, what is the current in that circuit. So that kind of a circuit is called LCR. ನೋಡಿ LCR, L ಅಂದ್ರೆ ಇಂಡಕ್ಟೆನ್ಸ್, C ಅಂದ್ರೆ ಕೆಪಾಸಿಟೆನ್ಸ್, R ಅಂದ್ರೆ ರೆಸಿಸ್ಟೆನ್ಸ್. ತುಂಬಾ ಚೆನ್ನಾಗಿದೆ ಅದು. ನಾರ್ಮಲಿ ಇಟ್ ಇಸ್ ಆಸ್ಕ್ಡ್ ಫಾರ್ 5 ಮಾರ್ಕ್. ಸೊ ಇನ್ ಕೇಸ್ ಆಫ್ ಕಂಬೈನ್ಡ್ all the components put together in series, avaga we have to establish what is the effective opposition to the flow of current, what is the current in circuit, what is the phase difference between voltage and current. Okay, right. Thank you makla watch ಮಾಡಿದ್ದಕ್ಕೆ. Thank you. We shall see in the next session